This is a presentation on 5G architecture and networking by Northam Basnith. So what is 5G? 5G is the fifth generation of mobile networks and significant evolution of today's 4G LTE networks. 5G has been designed to meet the very large growth in data and connectivity of today's modern society, the Internet of Things with billions of connected devices and tomorrow innovations. 5G will initially operate in conjunction with existing 4G network before evolving to fully stand-alone networks in subsequent releases and coverage expansion. So, how the 5G connected the community? In order to deliver faster connection and have a greater capacity, a very advantage of 5G is the fast response time referred to as latency. As you know, latency is the time taken for device to respond to each other over the wireless network. 3G networks, previous networks like 3G had a very typical response times of 100 milliseconds, 4G has around 30 milliseconds, and 5G will be as low as it can be of 1 millisecond. This is virtually instantaneous, opening up a new world of connected application. So what will enable the 5G? 5G will enable instantaneous connectivity to billions of devices. That means at the same time multiple devices can be connected in a single infrastructure with much more speed. Connectivity to billions of devices. The Internet of Things, also known as IoT, and a truly connected world. The 5G also enables the speed, low latency, and connectivity to enable a new generation of application services and business opportunities that haven't been seen before. For example, in massive machine-to-machine communication, we also know it's at IoT that involves connecting billions of devices without human intervention at a scale not seen before. Another is ultra-reliable low-latency communication. That means this includes critical tasks like including real-time control of device, industrial robotics, vehicle-to-vehicle communication, safety system, autonomous driving, and safer transport networks. Then third comes the enhanced mobile broadband. This provides significantly faster data speeds and greater capacity, keeping the world connected. The new application will include fixed wireless internet access for homes, outdoor broadcast application without the need for broadcast fans, and greater connectivity for the people to move on. Apart from this, we can also have the advantage of 5G architecture in communities, business and industries, new emerging technology like AI, and so on. So, how the 5G architecture works? Most operators will initially integrate 4G network with existing 4G networks. That means the previously existing 4G networks will work on the 5G network to provide a continuous connection. As you can see in the figure, 5G network illustrate 5G and 5G work in this figure. You can see 5G architecture is working with the 4G architecture to make a continuous connectivity to its users. A mobile network has mainly two parts in the 5G architecture network, and that is radio access network and the core network, which are described in coming. So as you can see, the radio access network and the core network are the two components that comprise the architecture of 5G, and they can be defined as. So what is a radio access network? It consists of various types of facilities including small cells, towers, masts, and dedicated building and home system that connect mobile users and mobile device to main core network. So basically it is a network that are built in various parts of the area, which communicates with the devices that are available near to it, or the users that gets connected to the internet. So this includes, as you can see, including small cells, towers, masts, or the nearby infrastructure. So basically this radio access network is, are usually built in small cells, which will impact in 5G network, particularly at the new millimeter wave, and which is also called wave frequency, where the connection range is very short. To provide a continuous connection for this particular radio access part, or let's say small cells, we have to build a cluster of infrastructure or the small cells around the users, depending on where users require connection, which will complement the macro environment that provides wide area coverage. 5G microcells will use MIMO, multiple input multiple output antennas that have multiple elements or connection to send and receive more data simultaneously. The benefit to users is that more people can simultaneously connect to the network and maintain high throughput, where MIMO antennas use very large number of antenna elements that are often referred as the massive MIMO. However, the physical size similar to the existing 3G and 4G base station antennas. So basically, small radio access network only focuses on the connecting this the infrastructure with the user devices, more like to have the MIMO antennas. So what is a core network? The core network is the mobile access and data network that manages all of the mobile device data and internet connection. For 5G, the core network is being designed to better integrate with the internet and cloud-based services, and also include distributed servers across the network, providing response times, reducing latency. So the radio access network, after connecting with the nearby users devices, they need to get connected they need to connect it with the another network, that is the core network, where there is a better integrated with the internet and usually are cloud-based services, and also it includes these distributed services, providing the less latency in the flow of the data in the internet. Many of the advantage features of 5G network, including function virtualization and network slicing for different applications and services, will be managed in this particular core network. The following in the next part, we will illustrate how the local servers, cloud servers, providing faster connectivity to the users, for example movie streaming with a low latency application for both vehicle collision avoidance system. So what is a network slicing? In this core network architecture, network slicing enables smart way to segment the network for a particular industry, business, or application. For example, emergency services could operate on a network side independently from the other users. So what is network function virtualization, NBF? It is the ability to instantiate network functions in real time at any desired location within the operator's cloud platform. Network function that used to run or dedicated hardware, for example firewall, encryption, business premises, can now operate on software on virtual machine. This kind of NF is very crucial in the architecture, or let's say in the core network, to enable the speed, efficiency, and agility to support new business application, and is also important technology for 5G ready core. So these are the two components that are comprised in the core network and helps to integrate or enhance the services of the 5G architecture. So in the 5G, so the next problem is how the 5G architecture works with the 4G. When a 5G connection is established, the user equipment or device will connect to both the 4G network to provide a control signaling, and to the 5G network, and to the 5G network to help provide the fast data connection by adding to the existing 4G capacity. When there is limited 5G coverage, the data is carried on the 5G network, providing the continuous connection. In this way, the cooperation between the 5G network and 4G network is done very nicely. Essentially, with this design, the 5G network is complementing the existing 5G network. So now there are different factors in which the 5G architecture working usually depends on, that is spectrum, obviously frequency, massive MIMO beam stream. So how the 5G architecture depends on the increase, or let's say 5G spectrum. So in many countries, the initial frequency bands for 5G are below 6 Hz. In many cases, it can be between 3.3 or 3.8 gigahertz bands, and similar frequencies to XCT mobile and Wi-Fi networks. Additionally, mobile spectrum above 6 Hz, including the 26 to 28 Hz bands, often referred to as millimeter wave, which we have discussed earlier. This millimeter wave will provide significantly more capacity compared to the current mobile technology. The increased spectrum in the mm wave band will provide localized coverage, as they only operate over short distances. Short distance, that is 5G network. The 5G network only uses the, after increasing the spectrum in the mm wave band, will provide only in the certain part of the area, let's say in the less area coverage. Future FTT developments may use frequency up to band of 86 Hz, which can be very useful. So massive MIMO input and output. Massive MIMO input and output. 5G will use the MIMO multi-input output antennas that has very large number of antenna elements or connected to send and receive more data simultaneously. Due to this, the users can connect to the network and maintain high throughout the network. The overall size of MIMO antennas will be similar to 5G. However, with the frequency, the individual antenna element size is smaller, allowing more elements in excess of 100 in the same physical area. Another is MIMO beam stream. Beam stream technology that allows the massive MIMO base station antennas to direct the radio signal to the users and device rather than in all directions. The beam stream technology uses this advanced signal processing algorithm to determine the best path for the radio signal to reach the users. So these are the components that 5G architecture usually depends on. So basically, 5G network, 5G has been a new concept to the world and usually introduced by the China, but so it has many possibilities in the field of autonomous vehicles, like safe driving, or let's say robotics, self robotics. For example, initially China used this 5G network to clean the to actually control the robot, or let's say the robot to clean the whole area, without any human effort. Another is that to achieve the low latency, that means the user get faster response times. Significant changes in both core network and radio access is very important, required to deliver the low latency. In the core network changes, with the designed core network, single and distributed servers accuracy is to move the content closer to end user and to certain part between devices for critical application. So RNA, radio access network change, actually achieves the low latency. The radio access network will need to be reconfigured in the manner that is highly flexible and software compatible to support their very different characteristics to the types of service that the 5G system invests on. So this is the overall 5G architecture. At the end, I want to say that 5G architecture uses the existing 4G architecture and works on it. There are different types of international networking network combinations, such as 3GPP, which actually works on the 4G architecture to develop a 5G architecture. So this is